Good to see you, Kasha.
Good to see you. Sorry to you and to the audience. We are running late, and
So let's speed it up a little bit. So basically, I'm stepping a little bit on the other side of the printed electronics, basically to the flexible base films. So Kimoto, we are a Japanese company founded in 1952. And what we basically do is we actually create flexible films with coatings. And we have actually 3 manufacturing sites, 2 in Japan, 1 in the USA, about 460 employees. And so basically, when we look at the core technologies we provide, we do coatings for light management, like light diffusion, light absorption. We do hard coatings and adhesives, as well as electric conductive coatings. And basically, these can be used as a base for printed electronics. And the question that we get more these days is like, well, how can we make these base films more sustainable? First of all, I would like to a little bit explain about the process. So basically, we start with a big roll-off film up to like 1.2 meter wide and 2,000 to 4,000 meter long. We actually apply a liquid coating in a roll-to-roll process. We can coat up to 3 layers per pass on our machine. And then we do fixation either by heat or by UV curing. And then we have an online quality inspection, and then we size it to whatever your process needs. And that is how we produce the films. Now, this is a basic structure of a film. So we always start with a base material. And this can be polyester, can be polycarbonate, or any other kind of flexible substrate. We add, in this case here, the example is like a hard coating on top of a polyester base film. And then we can add, for example, an adhesive layer to the back. So this would be your typical display protection film. And then there is in the base, there is also a release liner that protects the adhesive layer. If we look at the complete construction, we realize that the base film in this product is about 80% of the volume. So if we look at to optimize the sustainability, we certainly have to look at the base films. So base film selection is a key. And I think the most important thing here is what kind of options do we have? In the past, we have always used like virgin polyester. And now there is even options to go for recycled materials that have the optical and mechanical properties we need for our products. Or there is even some options for biomass-derived base films as well. The second thing is what we do in the coating formulation. Of course, we try to use a sustainable and conform ROS REACH and PFAS-free chemicals in the design stage. And then when we produce the films, of course, we try to optimize the energy consumption by reducing the number of passes. So to actually optimally use our coating capabilities of the machine. So in ideal cases, we can produce all the layers necessary in one pass. Then the last option is actually something that we have in a very special thing that I will introduce as a last slide is chemical-free processing. So changing the mechanical surface or the surface of the material in a mechanical way, so we don't need to use any chemicals. One of the most used base films we offer is polyester. This is also very popular for printed electronics. And right now we have the option of actually getting 100% recycled polyester films. And currently we are using these for display protection films, so like this example that I introduced in the beginning, and for light diffusion films. The base film is using 100% post-consumer recycled PET. So this comes from the typical polyester bottles for drinks. And so we have actually a certification according to the global recycled standard. And if we look at the process of making this film, 70% of the base film is regrinded and 30% is chemical recycling. So of course the chemical recycling will use more energy. And if you look at the savings of CO2 footprint of this recycled polyester, we look at about 32%